Hello, everyone. Hope everyone's enjoying EDA Summit 2023. This session is about enhancing RESTful microservices with event-driven architecture. It'll be mainly presented by Ashok Kumar Shankaran, who's a principal software engineer at JP Morgan. Here's the agenda for today's session. I'll be mainly covering a brief overview of application architecture, and Ashok will go in more depth and discuss what are common pain points of an architecture relying on RESTful APIs and synchronous communication only, and how you can leverage EDA with a hybrid architecture. Next. So let's begin. We have all heard about monolith applications and how they were really popular earlier when we didn't have the level of scale that architects have to plan for nowadays. Of course, monoliths have their advantages. They are well contained and easy to manage. However, when you start to scale, they're not a very good fit. And that's where microservices come into the picture. Today's applications consist of several microservices that are designed to fulfill a certain business logic. For example, in e-commerce, you might have an order service, a payment service, fraud detection service, order fulfillment service, and so on. So here's another example that demonstrates an order flow. We have a user on the left-hand side who will use the mobile app to submit orders. Another service, let's call it service A, is responsible for accepting this order and maybe doing some additional due diligence. Service B, on the other hand, is responsible for actually processing the order and persisting it to a database. Finally, we have two external services, external service A and external service B, which might be external to your application, organization, or even company. And they're also responsible for processing this order in their own way. If we dive a little bit deeper into the actual architecture, we can see we have a few components, such as an API gateway that is responsible for receiving all the client requests, authenticating the clients themselves, validating the requests, caching them, and routing them to the appropriate microservices downstream. Additionally, each service is communicating with others via synchronous RESTful APIs and request-reply pattern. Our services might also be separated to leverage CQRS pattern, which stands for command and query responsibility segregation. And depending on what kind of queries each service is handling, they might leverage a relational database or a NoSQL database. Now, I would like to hand it over to my co-presenter, Ashok, who will talk about common pain points with such an architecture and how we can enhance it. Over to you, Ashok.
Thank you, Himanshu. Hello, everyone. So as Himanshu pointed out, that these days, the enterprise applications are not built with using monolithic. It's all built using multiple services. Typically, in an enterprise functional flows, when a transaction comes into a system, it is not just they are entering in one system, they manually enter in multiple systems. It used to be the case. The last 6-7 years, a lot of modernization effort went in, and there is a lot of electronic connectivity, API connectivity that's going on from system to system. So as the industry got matured using REST, there were a lot of toolings available in the market that makes everyone to start using REST APIs because the maturity in the marketplace. So those yielded to synchronous interactions that how Himanshu pointed out, the architecture that was in the previous slide. But what we have seen over the period that is yielding towards some of these complexities that we are faced, like failure scenarios, poor user experience, the scalability issues, inability to add new services, and also, like, let's say if a data have to be consumed by multiple consumers and the complexity surrounding that. So let's look into each of these failure scenarios, complexities, and see how the newer architecture will come and solve this problem. So let's take this inconsistent state and complexity issues. So in the inconsistent state, what we mean here is, let's say a client calls the sales and says that, hey, I want to input an order. The sales puts an order, it gets routed through the order service, gets validated. And it is not like, as we saw before, it is not like one service does everything. That order service have to calls the external service, and after that external service is done, then it calls in another external service. So these entire data flow, if it is built using a synchronous model, the problem that where the issue started stemming up is when order service calls the external service A, when it calls external service B and crashes it. Now the sales service and order service know that, hey, the external service A crashed and it can compensate the transactions. But unfortunately, the external service B does not even know that external service A got crashed. So now the service A, when it wakes up, comes back again. It is in inconsistent state, and external service B will also be in inconsistent state. And compensating those states, it's not going to be simple. In order to compensate, they have to write a logic to have those states to be restored. On top of that, who is going to retry just because the external service B is being crashed? So those things add complexity into the whole end-to-end data flow. The second problem that we have seen that happening is the degradation of the user experience. When the sales puts an order on behalf of the client, they may not know, like, the entire data flow, like, the order service is going to call external service A, it's going to call external service B, but it is going to go through the entire synchronous calls. This adds the latency. So the total execution time is sum of all the downstream services. So this gives a bad user experience because the user now have to wait for 14 seconds to get the orders going. Now, the second problem that you will see in the synchronous interaction is the scalability issues. Because now order service, because the external service A calls external service B, and those are all external, so obviously it is going to take more time. So now the order service have to literally wait until the A and B service gets completed. When it waits, it means it is taking resources and it is making others not to use the resources it occupied. So it's wasting that and it's wasting the dollars. So now the third problem is, it is very typical these days because of like a lot of things happens in the industry. They want to make sure the the data flow, it's being monitored by analytics service, monitoring service, and some kind of a dashboard service. So in order to have an easy way to add a new service, now, let's say we are introducing a layer in between order service and external service. Now the order service have to change, and also the external service A has have to be changed. So these things adds complexity. There is no way that I can go and easily add a layer in between because of the tight coupling. So the problems that I just detailed, it's a very typical ask in an enterprise data flow. So how did we solve this issue? So one of the key problem that we are trying to find out, in back in days where people used to write a thick fat client jar and deploy it, and they do everything in one shot. Now they were split it using the microservice, but the problem is when you have an interface coupling and you have an interaction behavior coupling, what you end up in deployed is nothing but the distributed monolith. It's a very famous terminology that is being used, like where people break up the microservice, but they keep the interaction still synchronous. It is not going to yield them any benefit. So how do we break this? So the way we broke, we look at some of the core principles that we need to adapt. It has to be loosely coupled. We want to make sure that we can do one-to-many distributions. We want to make sure we can take the message and defer the execution until the system is in the stable state. And even when there is a failure, we want to make sure that we can reliably deliver. So the architecture that we saw before using the REST, using the API gateways, how it is being redesigned. We are not completely take away the REST. REST has a play. REST has its place. We want to use where REST definitely holds right, but we change in some data flows where it can solve the problems that is being hashed out on the previous slides. So now it has been changed where when the order comes in, when it gets internally validated, because we want to tell the sales saying that, hey, you did not put an attribute on for this order that needs to be, a mandatory attribute. So all those stuff, yes, synchronous integrations, we left it with the rest. But once the order attributes are validated and it is good to go, then we push that information to the event broker. And event broker takes it and acknowledges to the validation service saying that, hey, your order has been accepted for further processing. Then what we do, we use the state machines and we communicate back from the event broker to our UI in a real-time streaming to as the state changes at our downstream. Okay, so now let's see. So now as you see that the sales service calls the order service and so on. Now, let's say if the order service actually fails, or if any of the service fails, now it is not the responsibility of the service to make sure the order service gets the data. Even if it crashes, if it is not acknowledging back, the event broker takes the complete responsibility of handling those stuff. The retry logic, the duplicate events, and in case of failure in handling events, everything is being offloaded to the event broker. So now, if you look at in the previous slides where the total time of execution was taking like 14 to 15 seconds or 19 seconds, now the same thing, the latency, if there is any latency happens in the external services, it is not going to impact the UI, the user experience. So even if the external service takes more time because of the load, the way that this is being re-architected, once the data has been submitted to the event broker, the UI on the mobile service will say that the order has been submitted for approval. So if there is any kind of a long-running operations, any type of task that gets runs in the background, it can happen without impacting the user experience. And another important thing is, if an external service takes more time, my service, internal services, does not have to wait. So it is going to give up the resources to the other computing need. Plus, it is also saving the overall compute time on those infrastructure where it is running. Additionally, if my external service needs more scaling, I can independently scale the external service without even letting the validator service to know that I'm scaling. These two are very important to make sure the scale and resource utilization are kept at optimum level. SOC absorption. This is another big thing that happens commonly in the financial industry. As the market fluctuates, or a high-profile transaction that gets executed in any given time, that is very high demand happens. And these event brokers are well designed to take those kind of a load and give the consumer whatever the data rate that is being expected. And this gives a very fantastic way of handling any kind of a market events, which was not possible on the synchronous interactions before. The same thing, if I want to add an analytic service, as the data flows come in, the analytic teams, these days, there is a team dedicated for monitoring the data flow across the systems. So the data flow, adding a monitoring service on top of the data flow, it becomes super simple, because now to add a new service to an existing data flow, all we need to do is we can add just an additional consumer to the event broker without even impacting the validator service or any internal services. It's one of the key asks for every system these days built in. Hey, can I add this risk analysis? Can I have this analytic service? Can I have a dashboard service? This is a very common ask these days. So our system design using this becomes extremely agile. So all these problems are being taken out, as you see, using this event-driven architecture. We have a faster response time. We can parallelly process the messages. We have a better resiliency in terms of failure. We have a better agility in terms of adding new or adding and removing services. These are all very, very important requirements to satisfy these days on the enterprise systems. Thank you. If you have any questions, feel free to ask either me or Himanshu. We are happy to answer.